Today we're going to continue to take a look at expressions that involve exponents. In particular, we're going to look at some exponential equations. So we're solving equations that have a variable in the exponent. And it's worthwhile to sit back and think a minute about what an equation means, what the signs that are in the equation mean. And in particular, we're thinking about the equal sign. And for a long time in math, for my students, they feel like the equal sign just means this is where the answer goes. But it's important to recognize that the equal sign is in fact saying something different. It says the expression on either side of the equal sign is exactly equal. They have the same value. And once we recognize that, it starts to change the way we think about the math a little bit. So if the expressions on both sides of the equal sign have the same meaning, what does that mean then for an equation like this one? 3 to the x plus 1 power is equal to 3 raised to the 2x minus 1 power. So if we break this down a little bit, we have 3 raised to some power is equal to 3 raised to some other power. Now, how can these two things be equal to one another? And it seems that the only way that those two things could be equal to one another is if the exponents are equal. So 3 to the x plus 1 equals 3 to the 2x minus 1. The implication of that is that x plus 1 is equal to 2x minus 1. So let's solve that equation. So when we're given the equation, we can take the exponents, as long as the bases are the same, take the exponents and set them equal to one another. So now we're solving an equation with variables on both sides. So I'm going to subtract x from both sides. Now to isolate the variable x, I'm going to add 1 on both sides. And we find that the solution of this equation is x equals 2. So 3 to the third equals 3 to the third, and that obviously makes sense. So these are our steps for solving exponential equations. We're going to make sure that first we have the same base. So in this case, we had 3 to a power equals 3 to another power. If it was 3 to a power equals 6 to a power, we can't do anything with that. Once we have the same base, we make sure the exponents are equal to one another, and then we solve the equation for the variable, and we can go back in and check our answer, which we just did verbally. So let's go ahead and take a look at another example. 2 to the x plus 3 power is equal to 4 to the x. Well, what do you see that's different here compared to the example that we just did? Obviously, these expressions don't have the same base, so that's a problem. We can't just set the exponents equal to one another. But just because they don't have the same base doesn't necessarily mean that we can't move forward with this equation. If we take a look at the expression 4, we can see that 4 is 2 to the second power. So now I have 2 to an exponent equals 2 to another exponent. So let's rewrite that. 2 to the second is the same as 4, so 4 to the x is like saying 2 to the second to the x. And we can simplify that down. 2 to the x plus 3 is equal to 2 squared to the x. Remember, a power to a power, I'm multiplying my exponents, so 2 to the 2x so we can set equal the exponents. X plus 3 equals 2x. And now again, we're solving the equation with variables on both sides. So x is equal to 3. So 2 to the 3 plus 3, that's 6. 4 to the third. 2 to the 6th is 64. 4 to the third is 64. That one checks. Let's take a look now at some more examples. Now remember, A radical sign can be rewritten as an expression with an exponent that's a fraction. A square root radical, square root of a to the 2x minus 2, that's the same as raising that to the 1/2 power. A cube root radical is the same as raising to the 1/3. So we can rewrite those. So now recall that we can multiply the exponents, power to a power. So 1/2 of 2x, that's x. 1/2 of negative 2, that's 1. Here, 1/3 of x, 1/3 of 3. Now our exponents can be set equal to one another. If we multiply through by 3 on both sides, we can clear out this fraction. Scoot on over to the side here. So 2x equals 6. And then x is equal to 3. Let's take a look at another. 27 to the x equals 1/9. At first glance, these bases aren't anywhere near to being equal. How are we going to set this one up? Well, let's think about what we've got here. 1/9, 9 is 3 squared. 1 over 3 squared, that's 3 to the negative 2 power. 27 to the x, 27 is 3 times 3 times 3. So we have this. Three to the third to the x. So our exponent here is 3x and negative 2. We're going to divide both sides by 3, and x equals negative 2/3. Similarly, 49 is 7 squared. So we'll rewrite 49 as 7 squared to the x plus 1. Let's multiply these exponents. 2x minus 2. And now the exponents can be set equal. So moving through this pretty quickly, because these are pretty straightforward equations. Once we handle breaking down the base and rewriting it, usually these exponential equations involve solving some relatively simple equations of the exponent equal to the exponent. So divide by 3, and in this case, x is equal to 2. One last one. 125, that's 5 to the third. That table that you made at the end of last semester, that where you listed the perfect squares, perfect cubes, perfect fourth powers of different numbers might come in handy here. Now 5 times square root of 5. This is 5 to the first, 5 to the 1/2. This is 5 to the 3/2 power. Multiplying exponents here, 3x minus 9 equals 3 over 2. Let's multiply both sides by 2. So this one's going to be a fraction. We're going to divide top and bottom by 3. That's 7/2. So recapping our steps for solving exponential equations. We make sure that we have these expressions rewritten as exponents with the same base. Then we write an equation with the exponents equal to one another, solve the equation for the variable, and plug our value back in to make sure that our equation works. be sure to flip over the page and fill out your 3-2-1 note summary. So 3 things that you learned today, 2 things that you want to know more about, and a big question that you still have. And if you're the type of person who likes to maybe take notes with sketches, pictures, connections to other ideas or concepts in this class or other class, or just random thoughts, make sure you add those to your notes as well.